In this video, I'll show you why making USB projects has been so hard and how to avoid that. Easily make USB projects in as little as 10 minutes that work first time and won't break your bank account. This video is brought to you by Trace Systems Inc., the makers of HIDmaker and Simple Upgrade Management System. Download our free guide to USB success, Secrets of Successful USB Developers. USB is a convenient, easy-to-use, utterly reliable, extraordinarily flexible system for automatically connecting peripheral devices to computers that works fast on all desktop and laptop computer operating systems. That's the good news. But developers know there is a dark side to USB as well. It can be wicked complicated. The host side of USB was complicated to develop, but only needed on a few operating system platforms like Windows, Apple, and Linux. The big companies that make those operating system products already had a lot of highly skilled developers that worked on their operating systems, and these companies had sent key technical people who had deep knowledge of their inner workings of their company's operating system to the USB standards meetings to help design the fledgling USB system. These big operating system companies were also highly motivated to get host-side USB working because that let them get rid of the chaos of having to be able to support a different set of driver files for every different manufacturer of common peripheral devices like keyboards, mice, cameras. Moreover, each vendor's operating system is used by millions of customers, so they didn't need to make lots of different versions of the USB software. Getting the peripheral side of USB going was a different story altogether, with lots more struggle. Like with the host side, the peripheral side also required complicated programming, but the software had to be available for a lot more different microcontroller vendors and platforms that were considerably different from each other. Each microcontroller manufacturer would have a lot of different platforms for its own products, like 8-bit, 16-bit, and 32-bit processors, and even multiple different processor families within each processor size range. Microcontrollers have to be able to work with lots of different kinds of communication protocols. RS-232 serial, I2C, wireless, Ethernet, on, which put a big development burden on each of the microcontroller companies. USB was yet another protocol to get working with their processors. Particularly in the early days of USB, most microcontrollers did not use an operating system at all. Many of the most popular micros that are big enough to use USB didn't have enough program storage memory to contain an operating system. So the microcontroller companies couldn't just make one version of USB code that sits in a common operating system that all devices use. Instead, they had to make some kind of USB code and make a lot of different versions that could work in their substantially different processor types. As a result, the microcontroller companies didn't go deeply into USB to make it easy for their customers who are software developers. Each company made a few software demos, each with limited USB software that the company provided in source code. But if a microcontroller developer needed to make a USB project, he was expected to modify one of those complicated software demos. What developers invariably found was this: the software demos that the chip manufacturer provided would compile and run, but the demos didn't do what the developer needed their projects to do. When the developer tried to modify the demo source code, the USB communication would usually fail. The host computer would give little or no information about what went wrong, and the developer would not know what to do to fix the problem. Some developers were able to battle their way through to get their project to work, but this would often take months. And getting a first USB project working didn't necessarily mean that another USB development project would go any faster, because the developer would have to figure out how to fix different problems in each project. To this day, you can still run across some early USB-based products that were barely able to function. As a result, many microcontroller developers just gave up on USB or fell back to using virtual COM ports, the kind of USB that looks like their old RS-232 serial port communication with all of its limitations and clumsiness. This does not have to happen. And if it does happen to you, it is not your fault. The only surefire solution that we know of is an intelligent code generator like HIDmaker that requires only simple inputs from the developer and which generates matched custom source code for both the host computer and the peripheral microcontroller processor at the same time. This solution can get your communication created and working end to end in as little as 10 minutes. Yes, there is a better way. Question of the day. Have you ever tried modifying one of those USB sample projects to get it to do what you want? How long did it take? Thanks for checking out this video. Please subscribe if you're not already subscribed. If you want to, check out that free Secrets of Successful USB Developers guide with tips on getting your USB projects working end to end, really fast, every single time. Click or tap the screen in the description below. As always, we're helping you build your knowledge, skills, and impact with online video. Talk to you soon.